Hey, I'm Joshua Smith. I'm a solution architect at Temporal, and today I'm excited to talk to you about a multi-agent example application that I built that uses Temporal and MCP to do agent orchestration and task delegation. So for this example, I'm pretending that I am a wizard who works at Diagon Alley. My job is to make sure that the students and the staff orders for the people that attend Hogwarts go through and have no issues or problems. And so the students get what they need by the time term starts. I'm a little tired of looking through our order system and our inventory system and fixing things by hand and making sure orders get approved and inventory gets bought. And so I want to build a system that just does this for me magically. So I get emails like this that tell me, Hagrid wants his dragon egg order and maybe it's illegal and Hermione's order is delayed. And what am I going to do about it? And since I'm a wizard, I'm going to put on my wizard hat. All right. So let's talk about how to build an agent to solve this problem. I have built a few different agents. I'm going to walk through them one by one. So first, I have my detection agent. All that does is look at my orders in my orders database and see if there are any problems. And I define those problems using prompts to an LLM. So I just say, look for orders that are delayed or with a bad status or that might be a problem. If there are any problems, that will trigger the analysis agent, which will go deeper, look at my orders, my inventory, more data sources, and try to figure out what the specific problems are. Then we feed that information into an execution planning step that takes all of those analysis results and combines that with tools and proposes which tools to run for which orders to do the repairs. Then there's an execution step that executes the tools as planned by the planning step. And then there's a reporting agent, which takes all of this information, looks at the updated data in the inventory and orders databases, and gives me a report of the health of the orders and all the things that the system has done. And then there's me. I review the proposed repairs and I approve or reject the solutions to the problems that these agents found. And that part is an execution agent. It does the planning and the execution in interacting with me. And I have a wizard hat. So the next thing I want to show is what this looks like in my workflow history view. So here I have this temporal workflow that has done the steps that I talked about up to the notification step to tell me there are problems. So it's done detection, it's done analysis, it's planned the repair, and it's told me, hey, I have something you need to look at. Each one of these steps are activities, and this is a proactive agent. It runs and waits a while and then looks for problems. So I told it to stop waiting so I could do this demo. One thing I wanted to call out is each of these activities, I can look at their inputs. I can look at their failures. This one failed and then succeeded on the third try, and then the results. And that's really, really helpful as a developer because I can quickly debug issues, or if this was in production, I could debug production problems, and Temporal auto repairs any problems that I might have. Auto retries any problems I might have. So any temporary errors are just automatically resolved. The other thing that I thought was neat about this is I can set the workflow status, and I can also do a lot of queries that will get me my workflow data. So for example, I can get the, is the repair approved? False, because I haven't done it yet. Or I can do things like get the repair planning result and see all of the tools and their arguments and everything that it planned. And I can get all kinds of really nice information from the workflow run as it's running. Another thing that I think is really cool about this is I can go over to my worker. I have one worker here and it's running. It's my application in Temporal, and I can just kill it and it's dead. But because all of the state is stored in the temporal service and my workers can be scaled or killed or deployed whenever I need to, I can just restart my worker, and then my my application is running just fine. And then I can still, run queries. Like, it's 93% sure the repair is ready to go. And that's really cool. Temporal just makes building applications so durable and so visible, makes it really easy. So the next thing I want to do is show what this actually looks like in workflow code. So in Temporal, I define a workflow. I used Python, and really I just wrote out what I wanted to have happen. This is a proactive agent, so it runs in a loop, and it waits to do its analysis every loop. And then what it does is it does detection, like I talked about. And if the detection confidence score that there are problems is less than 50%, it says, we're not going to do anything today. Let's stop and try again tomorrow to look for problems. That's really nice. And the workflow, because it's just Python code, can take different code paths depending on what the LLM determines as part of the detection agent. Assuming we do have problems, like today, we can analyze those problems, create a plan, and then once the plan's done, we can check our planning confidence score. And if it's higher than 95%, I wrote the code that said, just go ahead and that's if it's below, we notify. But if it's above, we just self-approve and start executing the repairs. So it can act on its own if its confidence is really high. And then it runs the execution of repairs and per the plan, and then runs the report agent like I talked about. And I wanted to show an activity really quick too. Activities, again, are just Python code. Here's where we'd want to put anything that was possible to error or do things that are non-deterministic, that might be wacky. And we do that, and Temporal will automatically retry this if it has any failures. So here I go out and I set up my instructions for the agent, and then I call it. I really like Light LLM, by the way. And then I validate my results. And what's really interesting is if my results don't come back in the way I want with the right information or the right format, I just throw an error here, and that triggers the activity to automatically retry, rerun the agent, and keep going until it succeeds. And that's what happened in the demo. The LLM didn't come back with good information. If the API is down, anything goes wrong, Temporal automatically retries for me, which is really awesome. So now I want to show how it works to interact with this via Goose. Goose is a conversational agent built by Block. I really like working with it. And as you can see, it is suggesting some things that I can do. Goose is connected to my agent via MCP, and we'll show more about that architecture in a little bit. But every time I talk to Goose about orders, it goes out and connects to MCP, which connects to Temporal, and gets my information via queries. So we can see that my order is in pending approval. So what I want to do now is say retrievio order problems. Usually you could talk to Goose using normal Muggle language, but I thought it would be funny to speak wizard words to it and see how it did. So I'm going to say retrievio order analysis. So that's going out and doing the query that I showed and then telling me about all of the orders and their issues. And it says things like Ron didn't pay his bill. He needs maybe a payment extension or a reminder to pay. Hermione has inventory problems, so maybe we should order her more inventory. And Hagrid's dragon egg item is restricted, and we really need to approve that so he can get his dragon for mythical creature studies, I guess. So now I'm going to say Retrievio planned repairs. And what Goose does is it translates that into an MCP tool and then gets that information and then shows it back to me, which is really, really awesome. This UI is great. And it shows me this is what the system wants to do to repair these problems. So order spew badges for Hermione, prompt Ron to pay, and request approval on this order. Awesome. Those all look good. So I'm going to say executio repairs because I'm a wizard. And now the repairs have been approved. So I am going to go back and look at what that looks like in my workflow. So workflow is fine, even though I killed my worker. It's all working great. You can see the approve repair came in. This long bar was a timer. It waits for me to approve. Otherwise, it just tries again for the next day. So it sent a signal to approve the repairs. It executed the repairs, and I can look in and see, oh, it took one attempt, and these were its inputs and its outputs. Everything went great there. And then I can check out my report. Totally worked great. Everything worked fine. So it ran the tools and it did a repair. Everything's working great. So that's neat. But usually I wouldn't do that. I would just do all this via my conversational agent. So now I'm going to say Retrievio repair report. I don't really even have to spell well, but it's habit. So now it goes out, runs a query, and checks in on my workflow and gets the repair report. And I can see my confidence score that the repairs were sufficient is 93%. We repaired 3 issues, and these are all of my orders and their status. And we can see we sent our approval request for a restricted item. We can see that we did a restock for the spew badges. And now Hermione, using the power of magic, we automatically, instantly got a delivery of spew badges, maybe through the Flu network. And then boom, that owl's out the door delivering that order. So she's all set and her order is delivered. And I don't get angry Hermione emails anymore. So the system works, and it's gonna sit around and wait for another day, check orders again tomorrow, and then we can do this again. And this makes me really happy because all I have to do is approve the repairs using my agent, and I don't have to do it all by hand. So let's just talk a little bit more about the architecture here. So just to give a detailed overview of what this system's architecture is, there was me with my hat talking to a conversational agent, that was Goose, and using MCP to interact with my temporal workflow. And my workflow durably executes the process as I wrote it out in Python. It tracks state, it decides on actions, it takes different paths, and is dynamic depending on what the system is telling it, what the orders are, what the LLM agents are doing, all of that. The workflow takes different paths. It also orchestrates a detection agent. And the detection agent is got its own intelligence, detects problems, reads the data. The analysis agent goes a little deeper and thinks about the inventory as well, and also goes and tries to define what all the problems are. It plans repairs. If I approve it, it executes repairs. That's part of the main workflow agent. And then it orchestrates a final report agent, which does the final analysis of the system. The detect, analyze, and report agents don't have any write access. They just read data and use the context as it's built. But the main agent in the workflow does write to the database. And One of the things that I really liked about building this system was a pattern emerged. And I tried to put a useful acronym around it, Dapper, which is detection, analysis, planning, execution, and reporting. Some systems can be built to be event-driven or get a signal to say, hey, there's a problem, and they can skip the detection step. Some systems maybe are fully automatic and you don't need to have a separate planning and execution step. I really like that, just to have a human in the loop to interact with what your system proposes. And sometimes you may not need a report step. Maybe that step is just a summarization of the plan execution and say it was done. But I liked having that final analysis to read my data sources and make sure that everything was okay. And it's Dapper. I really like Temporal because Temporal makes all of this super easy. It gives me durability, visibility, and simplicity. Workflows enable the interaction that we showed with sending signals and getting queries, orchestration of all of these agents, dynamic decision making, and it can run for days, which is really, really nice. I can kill my workers when the workers aren't executing workflows. They're not using any resources, and it gives me this nice auto save, as you saw in my workflow history. And activities give me a lot of power to re-execute things if there are failures. It just automatically did that for me. I didn't have to write any extra code to do retries for my external calls to the LLMs or to read data. So the Hogwarts kids are happy, the staff is happy, they have what they need, and magically all of the orders got resolved. And I just wanted to leave you with, I really, really enjoy building systems with AI. I think agent architecture is really powerful. And it's also a ton of fun to just write out what you want to happen in a prompt and have the system do the work for you. It's really, really cool. So AI is a lot of fun, and Temporal really gives it a lot of power. And together, Temporal and AI are just magical. I hope you enjoyed, and if you want, check out my code that's